Yeah, participants. The speaker, the resource person for the session 2 of FDP of today's session is Mr. Jawad, Mr. Mohammad Abdul Jawad. He is a CEO of High Octanes Lab Private Limited, Hyderabad, as well as Embedcom Technologies, Canada. Mr. Jawad has a degree in BTech in Electronics and Communication and MS degree from Germany in IT and Automation Systems. Mr. Jawad has over 2 decades of experience in designing embedded systems solutions in the fields of automobile, oil and gas, and industrial controls. His work contributed in building IEC standards and solutions globally implemented, smart meters, AMI, etc., creating innovative ecosystems for industry and research, excelling in embedded systems. He is currently designing products for remote monitoring and control for predictive maintenance, creating digital twin. Now, I request Mr. Jawad to take over the sessions.
Hello, everyone. Assalamu alaikum. Good evening. So, yeah, thanks for the warm welcome. So, yeah, before I start, I would like to, thank the platforms in which, it is encouraged for faculty development programs are done so that there is a connect between the industry and the academy. So this was a passion, after my education, I wanted to bridge that gap. And there's a reason you see me here. And I really thank the ATAL platform and the Manu management for having me and inviting me for this session. So yeah, so here I'll try my best to show, present what the industry is currently doing in this arena. And of course, let me share my screen. Let me see my screen. Let me see. So, can you guys see my screen? Any one participant, Madam Hajara, can you see my screen?
Yes, sir.
Yeah.
Yes, sir.
Great, great. So, well, as Madam mentioned, one of the companies I'm running is Embedcom Technologies. So we are more into green solutions, where we, kind of develop products to preserve the natural resources and to make optimum use of energy. So we are into that part. So of course, sustainable urban energy planning encompasses a lot of things. So Embedcom Technologies touches a couple of them, which I'll of course emphasize on what on how we are trying to support this entire ecosystem, and not least the upcoming smart cities, how they are planned, and what Embedcom Technologies' role is in developing those smart cities. So let's get started. So yeah, so what overall what we would like to here represent is the sustainable urban energy planning. Of course, as per the definition, we kind of determine the strategies to manage the generation part and the consumption part. So of course, I'm not much into the generation part, but of course there are tons of information available. There is plenty of work done by various institutes on that part. So I kind of stole the data from them, courtesy on their courtesy, and then we are mostly involved in the optimization on consumption part. So emphasis will be given on consumption, but of course I present how generation is done in the current generation. So what's the whole goal over here? Here is to reduce environmental impact and increase energy efficiency, and of course to secure the energy for generations to come. What we will be focusing in this presentation is energy efficiency, renewable energy integration. Once we have that renewable energy, how will we integrate in our existing platforms? And the smart grid technologies, what technologies are we using to use the energy efficiently? So that's the smart grid technology, what we are actively involved in currently. And sustainable transportation, we are not much involved in this, but of course there are lots of development going on for transportation. I'll give you with some case studies of which country is doing what in that aspect. And then last but not least is this energy storage, how we can store this energy and so on. So yeah, let's get started. So what's the problem? So we know that, I bet you guys have heard about greenhouse gases. So we are the culprits for them, and a human being, because of its greed and pulling more than required. So we are creating some unwanted atmosphere within our planet, and then we have, of course, it comes with some cost. So once this gases are emitted, and undesirable gases, what we already know, it's CO2, it's methane, it's nitrogen dioxide, and there are tons of fluoric gases released in the atmosphere. So what's the problem with this? So the problem is, once these gases are emitted, then the atmosphere has those a layer is created, and which the energy which comes from the sun, heat energy, is being absorbed on the outer layer of the atmosphere, and they are not emitted in the space. So there is effect of heat. Of course, in the next slide, I'll elaborate on what different areas these affect our Earth in all. So the basic reason is to control these emissions, greenhouse gases. So I want to emphasize on this slide, just because we know what we are targeting, and how countries are collaborating to reduce these greenhouse gases. So of course, to know what are the sources of these gases are power plants. When I say power plants, I mean when you generate electricity. So you use fossil fuel to generate electricity, and because there is a huge demand, and once you generate that amount of gigatons of wattage, there is an emission, and that emission is irreversible, and that is affecting the entire greenhouse gas emission. So power plants is one of the major things. The other one, of course, we know, is the pollution from the vehicles, and of course the manufacturing industry, you name it, all kinds of manufacturing industries, the commercial and residential buildings, agriculture, and the expansion of the land use in the urban areas, and removal of the forestry. So these are the causes for our greenhouse gases. So coming to the next slide, I think is the continuation of the problem statement. So now, once we have this unwanted gases, what's the impact for that? So the impact on them is, of course, we thought it was a myth, but now there is an evidence that the temperature is rising. So we see that heat in the atmosphere that's leading to global temperatures. So now what happens because of that is, of course, it's an ecosystem. So one thing is disrupted, everything gets affected. So what are the effects? It's climate change. So we see increased, greenhouse gases cause shifts in weather patterns, including more extreme temperatures, storms, and droughts. And we have the melting ice caps, which normally you see in polar, icebergs. They are melting, and the result of that is the rise in the sea levels. And so the next is the acidification of the ocean. So higher CO2 levels lead to more, CO2 being absorbed by oceans, making them more acidic and harming the, ocean life. So the next one is the disruption of ecosystems. So altered temperatures and weather patterns can affect biodiversity and disrupt ecosystem. Of course, we have, because everything is interconnected and not isolated with each other. So it's the ecosystem will be, gets affected by this. I'm not sure whether I pulled the slide for number of deaths happening because of the atmosphere, but there was a statistics that shows how many deaths are happening just because of the, polluted, gases. So here, higher temperatures, air pollution, this could lead to, respiratory problems for human being and heart-related issues and spread of diseases. So yeah, so there's a very interesting study done on this. Besides accidents happening by transportation and so on, there is a statistics present to show the evidence for that. Agriculture, yeah. So India plays a lot of role in this agriculture. The ways we are using and to do the agriculture that can, changes in the rainfall and temperature patterns affect crop yields and food security. So these are the effects of the fundamental, emission of greenhouse gases. Moving on to the next slide. So yeah, so now in other terms, we call that, carbon footprint. So we encourage the, the companies, manufacturing industry to have as less as possible the carbon footprint for whatever they are producing. So a carbon footprint, measures the, so what's the definition? Let's say the definition is the total amount of, how do you, there should be a KPI for that. Yeah, you should measure that. It should be measurable, right? So the measure is, of course, the gases. So out of the CO2, methane, nitrous oxide, how are we measuring? So important part is the, of course, the carbon dioxide, CO2, and of course we know there is a methane as well. But our emphasis in the I think this is the 70% of the entire greenhouse gases. So we express that in the equivalent of tons of CO2. So yeah, so this is a brief definition of the carbon footprint on that part. And coming to the statistics of the globally, what are the rates? So I tried to pull the latest information on this. I don't recall exactly. It's a World Bank for data on GHC. So what we have seen here is, as you can see, as I have mentioned, the yellow part is the power industry. So this is the major contributor of greenhouse gases, and the other one is the manufacturing, where you have lots of unwanted gases being released in the atmosphere, and there is in transportation we have aviation, and so on. So agriculture is not least. So these are the statistics, and you can see a small dip in 2020. I guess you know why this dip is. I think you guys can guess on that. So there was pandemic, so we saw the dip in that. So there is an evidence that, I mean, if we burn less, then the environment is being secured. So yeah. So right now we are sitting somewhere in 53 gigatons, 53 gigatons of CO2 equivalent. Okay, this is global. So now I thought, let's, because we are sitting in India and we know what India is playing a huge role in contributing to this. So in India, there was a study conducted by the same institute, and they have given us the statistics for all the countries. And I put the chart for India, and again it says the major is coming from power industry, and then we have other manufacturing industries, and not least agriculture. So yeah, out of the in all the gases I have shown in the earlier slides, there were CO2 and nitrogen dioxide, methane. So the major contribution is from CO2, and the second biggest culprit is methane. Yeah. So yeah. So by the way, you guys can simply interrupt me if you have any questions or if it is not clear. So yeah, I can simply stop and then answer your question, or you can do that after the end of the session as well. So now we know the problem, we know the statistics. Lots of companies have contributed in getting the data, and we understand the problem. So now, what's the solution? So some countries came together and they said, let's try to work to reduce these emissions. So there was a Paris Agreement, which is it's a global treaty under UNFCCC to combat this climate change, limiting global warming, of course. And what does that mean? Is to not have the temperature rise below 2 degrees. So this was the aim, that we have to get our atmosphere as good as it was in 1800s to 1900s approximately. So yeah, so what is required in that? It requires countries to submit nationally determined contributions, update them every 5 years, and strengthen climate resilience. So this was the mandate given whoever was into this agreement, and many countries participated, including India. And showing further slides, what are their promises and what are the numbers. So now, developed nations pledge the 100 billion annually to support developing countries, but of course there was a shortfall on the contributions, and there is some hiccups in achieving the targets, but still they did not give up, and the countries are still working towards that. So here we go with the Paris Agreement, and let's see what's coming up. So now, so yeah, so coming back to our main goals, what we have started with. So we understood the problem statement. We understood what the countries are trying to do to solve the problem, and now let's highlight on some of the aspects what is practically being done. So the first thing is renewable energy integration. Of course, once you have that energy, how will you integrate with the existing infrastructure? So I slightly touched on highlights the use of solar, wind, and geothermal energy in this, and then in energy efficiency, which is again a priority, because if you remove efficiency, then what all we are producing is wasted. And we have seen with evidence that if we develop an efficient system, 40% of the energy could be preserved. So when I say preserve, you need not generate that. So it's kind of supply demand study. So 40% is not a less number. So what does efficiency focus? It focuses on improving building designs, utilizing district heating, and adopting energy efficient appliances. Because we are into embedded systems, electronics, and mechanical, so we kind of try to provide solutions in which the appliances they use less energy, and they do the same amount of work. So yeah, we got a quite good hold of developing or getting a statistics on the applications. Yeah, there are various applications like HVAC system, and there are smart grid, in oil and gas, automotive industry, and yeah, so there are lots of applications for that. Now, coming to the urban form and land use. So here the idea is to promote compact when planned spaces to minimize energy consumption, so that if there is new development, so we can plan ahead how the infrastructure can be planned, so the energy will be used optimally. Next is the smart grid technologies. As I mentioned, embedded technology is quite ahead in this sector, and this involves real-time energy distribution and effective demand management to optimize energy use. And yeah, so again, this is about this study of supply and demand to match them and use it efficiently. Sustainable transport, it encourages adoption of electric vehicles. I think you guys have already seen on the streets, we see the electric vehicles, and so we have less emissions, enhanced public transportation, and many countries adopted, literally they adopted the cycling to reduce emissions. Yeah, this keeps us healthy as well. Yeah. So not least energy storage. So we emphasize the importance of technologies like batteries and pumped hydro storage for storing renewable energy. So we will kind of, the next slides, we'll try to focus on these elements of what I have briefed up, and of course you guys can stop me or question me if you have any questions on that. So a quick again on how we can efficiently use the energy. So this is one of the important studies and analytics of what's the demand of the humans on energy part. So what does it do? It refers to using less energy to perform the same task or achieve the same outcomes. It involves optimizing energy use across various sectors. So it's transportation, industry, buildings, appliances, by adopting technologies, practices, and behaviors that reduce energy waste. This is very important, right? So we have to reduce the wastages. So how can we do that? Building insulating homes, using energy efficient appliances, and implementing smart energy management system. This is one of the biggest things what major companies are working towards that. Transportation, improving vehicle fuel efficiency, transitioning to electric vehicles, and using public transport or shared mobility. So we have lots of countries stepping up to solve the transportation issue and using it in an optimal way. Industry. So using advanced technologies and processes that require less energy for production, such as efficient motors and heat recovery systems. So next one is the renewable energy integration, increasing the use of solar, wind, and hydropower to provide clean energy, reducing reliance on fossil fuels. So maybe I did not use that words earlier, but the whole thing is happening because of the current use of fossil fuels, because this is irreversible, this is non-renewable energy. So this is what we want to get rid of, right? So next is now we're focusing on actual. This is the absolute solution the world is moving on. So what is that? Is the renewable energy. So renewable energy is the energy that comes from the source that won't run out. These sources are abundant and sustainable, making them the key to reducing greenhouse emissions and combating climate change. So yeah, so we love this method. We want to go for this because it affects less on the planet, healthy living, and so on. But we have to do a little sacrifice for that of using our resources in an efficient way, or an optimal way. So major types of renewable energy include solar. We heard of that. Yes, converting the sunlight to electricity. We have wind energy. We have hydropower. We have geothermal energy. That is, of course, heat extracted from beneath the Earth's surface. We saw the use cases of hot springs. I'm not sure whether I included a slide on this, but yeah, they are literally hot springs coming out of the earth, and we can make use of them. Biomass is not least energy from organic materials like wood, crops, or waste. So yeah, these are our ideal sources of, or should be, what we are currently working on to generate the energy instead of using using fossil fuels. So we don't want to use fossil fuels because it's irreversible, it's non-renewable energy, and we want to avoid that and move to the renewable form, which is the 5 forms what you see on the screen. Okay, so advantages of renewable energy includes this low environmental impact, infinity supply and potential for local energy production. Challenges involve initial setup costs, variability of sources like solar and wind, and the need for technological advancement in storage and grid integration. Of course, if I want to have my electricity bills reduced a little bit, then if I plan for a solar on my rooftop, then there will be an initial investment. But that initial investment, which ROI, what we call that, and that could be regained, if not in few months, but in few years. That cost will be easily, regained. So yeah, there is of course an initial, setup cost for these kinds of, ways to generate the energy what we are willing to use, which is electricity, for example. So yeah, what comes next is very interesting topic is smart grid technology. Of course, this is our subject. What EmbedCom Technologies is deep into this, but of course, I did not put tons of slides for that. I would love to answer any questions on this. So yeah, so the other way to, okay, once we produce energy, so how to use it? I mean, now we have plenty of them. Can we use it as we wish? No. So we need to find out how much we actually need, right? So we have smart sensors, smart meters. We have tons of ways to determine what's our requirement, what's the demand. So once we know the demand, then we can alter the production part. So yeah, so smart grid technology is a collection of advanced technology that use digital communication and intelligent devices to monitor and manage the electricity distribution network. So when we say two-way communication, that means that not only the consumption is controlled, but also generation is controlled. Smart grids use two-way communication to allow for the flow of electricity and information in both directions. So that's the reason we use demand and supply will be kind of a closed loop is happening here to determine when to generate as per the demand. So real-time data, smart grid uses sensors and automation to collect real-time data, energy usage, and grid conditions. So smart meters, we already see smart meters in our homes that logs tons of data to measure. Everybody in the evening they start using all their appliances like washing machine and their what do you call that, stuffs which run on electricity, and the consumption is huge in the peak hours, maybe 7 a.m. to 9 a.m. and then in the evening, and in the afternoon it's almost idle, sitting at nothing, bare minimum consumption. So to optimize this peak hours, once we know the statistics, then the supply could be managed. So renewable integration is the smart grids can integrate large-scale renewable energy sources like wind and solar. And then we have the demand response. Smart grid can use demand response to manage electricity demand. This is what I was mentioning. Okay, so let's see what comes next. Now comes the transportation part. Very interesting part. So we have been looking into the transportation since decades, and we have seen, now, if you go on the streets, you have to put the masses. Example in New Delhi, you simply cannot, walk on the street, and if a person is already have respiratory problems, he cannot walk on the street in New Delhi. Thanks to, still, we are in the south part here in Hyderabad. Still, we don't see the worst case. But this is one of the important things. But if we don't take control of this now, then we could face similar issues in the future. So what is expected out of this transportation is a sustainable transport system. Refers to a transportation network that meets the mobility needs of people and businesses while minimizing environmental impacts, conserving resources, and promoting social equity. So what are the key components for this? Is public transport. So we have the public transport we see powered by clean energy. I think I'm not sure whether we see that here, but in Europe, definitely they have already stepped into it. And we see the trains and trams being, powered by electricity. Powered by, batteries. So now comes the active transport promotes. This is again normally we don't see that here in India again, but in European countries they have made a special, dedicated lanes for bikers and pedestrians. So the infrastructure is very friendly for them, and they can commute to one place to other, and it's healthy as well. And the other one is the electric EVs. I think it's already in action. So we see electric vehicles on the road, and this, of course, will reduce the emissions as compared to burning the fossil fuels, what we have already seen in the past. So yeah, countries are increasing their EV charging infrastructure and offering incentives for EV adoption. It's true. Yeah. So shared mobility is car sharing, bike sharing programs, reduce the number of private vehicles on the road, easing congestion and lowering pollution. And these systems provide flexible, cost-effective options for urban residents. So yeah, it's a culture in some countries that you go from one place to other place, and they simply put in some platform or group that some has to share a ride from this place to this place, and the guy simply says, yes, I'm available, and they can simply share the ride. Okay, so now comes the integrated transport system, a seamless and interconnected network of public transit and cycling lanes, EV infrastructure, and walking pathways, as I mentioned earlier, helps improve accessibility and reduces the need for private car use. So this was for the transportation. I think in next slides you might see some examples, but let's see. Yeah, I think it's continued here. So some examples I try to pull from different countries. So we have seen electric buses, autonomous vehicles, and smart traffic management system can help optimize routes, reduce congestion, and improve air quality. So it's not just coming up with a generating a renewable energy from wind or hydro, but it's about how you use it. If you use it efficiently, if you have a smart city built efficiently, then you can kind of utilize that in a better way. So technology like ride-sharing apps and mobility as a service platform allows users to can adopt on this platforms and reduce on the GHS. Next, transit-oriented development is promotes higher density mixed use developments near public transport. It helps in reducing the need for long car commutes. Okay, so this again kind of organizing the transportation, designing cities to prioritize walking, cycling, and public transport over private vehicles. So now we have the examples of sustainable transport system. So in again, as I mentioned, Europe is quite ahead in this aspect, and in Denmark, so known for its existing cycling infrastructure with more than 390 kilometers of dedicated bike lanes, making cycling the preferred mode of transport for many residents. So yeah, so this is very intensive way and to stay healthy as well. The city has electric buses and aims to have carbon neutral transportation by 2030. So that was Copenhagen, Denmark. So Netherlands is again a very intelligent step of taking into cycling, with around 38% of all trips made by bike. This is a huge number, 38%. The city has electric trams and aims to transition zero emission public transportation by 2025. So we are into it. I did not get the update for that. Let's see what happens. So next slide is storage. So in the storage part, we have the, of course, we have seen the lithium battery in the market, and we can use in large scale to store the energy what we are generating. So why do we need to store? So it's simple, right? So on the peak demand, we need not generate that much of energy, and we can use it from the stored resources. So the other types are solid state batteries and the flow batteries. Where is solid state battery, new technology with higher field energy density and improved safety compared to lithium ion, and the flow batteries is more towards liquid electrolytes to store and release energy. So coming to the pumped hydro storage. So water is pumped to a higher elevation during low demand and released to generate electricity when demand is high. It is most widely used large-scale energy storage method. So I'm not sure whether I pulled some use cases, but this is also one of the efficient ways to for storage of the energy. So compressed air energy storage is air is compressed and stored in underground caverns or containers during low demand and then released to generate power during high demand. Compressed air energy. Thermal storage, a molten salt storage used in solar power plant. It stores heat generated during the day and releases it to produce electricity at night or during cloudy weather. Ice storage is used in cooling systems, of course, to store ice during off-peak hours and use it for cooling when energy demand is higher. So why do we need to store? Of course, we need the grid stability, so that when the demand is high, we are not putting complete load on the grid, but on the generation part, but we can also use it from the stored energy. Helps balance supply and demand, ensuring consistent electricity supply. So renewable energy integration is the important part. Stores excess energy from renewable sources for later use, enabling a higher share of clean energy in the grid. So cost saving optimizes energy usage and reduces the need for expensive peak demand power plants. So yeah, of course, if we of course, it's common sense that if we happen to store that energy and during the high demand, we don't need one more plant to produce the required power for that demand period. So this is kind of very easy way if we kind of store the energy in the methods I just mentioned. So yeah, the future is going towards smart cities. Everybody wants to live in convenience and with pay less bills. Of course, we'll pay less bills if we use less energy efficiently, and and all city is the ecosystem is developed to somebody wants to in the ambulance, they take forever to reach the emergency the patient in emergency. So everything will be interconnected, and the livelihood will increase with smart cities. It's not just conveniences. We not only reduce the gases, but our livelihood will be improved as well. So definition of cities that use digital technology and data to improve the quality of life. Of course, what I mentioned, quality of life is important. This is the final target. Increase efficiency and promote sustainability. So we don't want to use everything and leave nothing for the coming generations. So what do smart cities do? So you heard of Internet of Things. So we hook up sensors in almost all the infrastructure to get the data. Once you have the data, then you can make decisions on that. So data is the new oil. So connected devices for city management, like for example, traffic, as I just mentioned. Imagine a ambulance never has to face a traffic signal. So it's green, green, green for ambulance. Imagine that system. So for that, we need to have the devices connected to each other to manage that ambulance, take its optimal route to go to its destination. Data analytics, real-time data for decision-making optimization. I think you heard of artificial intelligence and machine learning. So we can make use of those for data analytics. Smart infrastructure, energy efficient buildings, smart street lightings, intelligent transport systems will be effective for using the energy efficiently. A digital platform for residents to participate and interact, to share their complaints and so on, so they can let the authorities know what problems they are facing, and then two-way communication can resolve lots of problems. Sustainability, reduce carbon footprint, renewable energy, waste management, as I mentioned. We don't want to leave the bad world for the upcoming generation. Resiliency systems to anticipate and respond to climate changes. So this was with the smart cities. Let's see what's coming up. So now, how can we link the sustainable energy to the smart cities? So now we have to integrate the two parts. So ASEMEP provides the energy framework for sustainable urban development, and smart city technologies enable the efficient use of energy and data-driven solutions. So integration with the smart grid is what I emphasized on, is how demand and supply could be managed well. That could only happen if you have enough data to analyze, and then you can produce the appropriate amount of energy. The smart grid is one thing. Renewable energy systems are integrated into urban infrastructure, of course. Yeah, energy efficient transportation and building system are enhanced by technology. So the measures what we have seen in the transportation and the building systems, not least, and use of technology. So it's an ecosystem. So only one aspect will not be enough to drive this or make this happen. Okay, so what we have concluded in the entire, I guess, 45 minutes is here. The renewable energy and smart cities are crucial for developing sustainable, energy efficient and livable urban spaces. Combining smart technologies with sustainable energy planning enables cities to tackle modern challenges like climate change, pollution, and resource depletion. We have learned this. So what's the goal? Create cities that are technologically advanced, environmentally friendly, and resilient for future generations. So this is our entire aim, is to, of course, reduce the use of fossil fuels, thereby affecting or reducing greenhouse gases emissions, CO2, and the effects so forth, and developing smart technologies to use the energy generated in a sustainable way, and of course use it efficiently. So this is the complete ecosystem what we have concluded. Any questions so far? No comments, then I will proceed with the next slides. So I don't see any hands raising. Okay. Okay, so now nations working towards this. So I put some use cases, the practical, what countries are currently contributing to that. Hopefully in the next 15 to 20 minutes, I think I can discuss on this. So what countries have promised? as part of the global efforts to reduce the carbon emissions. So countries have established limits for targets through agreements like Paris Agreement, aiming to keep global warming below 2 degrees, ideally 1.5 degrees centigrade. Yes, these targets vary widely. So now we have European Union. So the European Union has grouped together as Europe, reduce emissions by 55% by 2030 compared to 1990 levels. So we are comparing always with pre-industry era. So because we think that after the industry era we have polluted enough, so we kind of go back to that era, and we have to achieve that 55% by 2030, achieve net zero by 2050. This is a big achievement. So yeah, so let's see. Carbon market, the EU emission trading system caps emission for industry. So yeah, they will cap the emissions for the industries. The more you have the carbon footprint, the more will you be taxed. So United States target reduce emissions by 50 to 52% by 2030 compared to 2005 levels, achieve net target by 2050. Policies include incentives for renewable energy and electric vehicles under the Inflation Reduction Act. So they have created their own incentives, ways or encouraging the citizens to how they can move to renewable energy. For example, that you can use solar panels in your homes and use electric vehicles, and they will be given with incentives. China, peak emissions by 2030 and achieve carbon neutrality by 2060. So China is the world's largest emitter, but heavily invests in renewable energy. I think I'm not sure country-wise did I include the chart. We have seen China in the chart is the one which produces the most, and then I think US or India, something like that. Yeah, India contributes approximately 7.5% of the global emission. So let's continue the limits by major countries. So India reduce emissions. The target is intensity of GDP by 45% by 2030 from 2005 levels, and achieve net zero by 2070. Focuses on renewable energy expansion and afforestation, plantation. India focuses on lots of plantation, so that is one way it is planning to reduce the greenhouse gas emissions. Canada is, reduce emissions by 40 to 45% by 2030 compared to 2005 levels, achieve net zero by 2050. Implements a national carbon pricing system. Australia, similar 43% by 2030 compared to 2005 levels, and net zero by 2050. And renewable energy policies are a primary focus. Renewable energy policies, yeah, what we have spoken about, I think the wind, I guess. We'll see in the next slides maybe for Australia. So Japan reduce emissions by 46% by 2030 and compared to 2013 levels, net zero by 2050, prioritizes hydrogen energy and carbon capture technologies. So now there are some countries, I have pulled the data on what the other countries have achieved so that India can adopt similar but the use cases what we see in the existing success stories. So it's Finland, smart energy solutions and carbon neutrality is smart district energy. Helsinki is working on a smart district energy system where buildings and energy system communicate with each other to optimize heating, cooling, and energy usage. The system is integrated to renewable energy sources to reduce carbon emissions. Carbon neutral city, again, Helsinki aims to be carbon neutral by 2035. To achieve this, the city's transition to renewable energy, improving energy efficiency and promoting electric mobility. So smart water and waste management. Helsinki also uses smart systems to monitor water and waste, optimizing the use of resources, and reducing energy incentive waste treatment process. So yeah, water is not least, I have seen water meters, but in India still they did not, monitor the actual consumption. They put a cap on the extraction of underground water, but they actually don't, regulate it. So yeah, but in other countries they have their, like we have, the electricity meter, they have the water meter being built every month. So here, of course, we have the meter, but I'm not sure. It's not as active as we have in European countries. Yeah, India is very, of course, active in electricity part. If you don't pay the bill, within, I think, 3 weeks, the electricity will be disconnected. But that's not true for water. Okay, so next is the Singapore smart water management and energy efficiency. So smart water management, Singapore uses a smart water management system to monitor and optimize water usage across the city. Sensors track water consumption, as I mentioned, it's very important in real time, and the data is used to manage resources more efficiently and reduce waste. Solar energy, Singapore has also invested heavily on solar energy, installing solar panels on rooftops and integrating them into the power grid to promote renewable energy usage. Green buildings, the city promotes green buildings standards through the BCA Green Mark certification, encouraging buildings to adopt energy efficient technologies such as solar powered water heaters and smart lighting systems. Not least smart lighting systems, it's it's all automated. I mean, if you don't use it, it shuts off on its own using advanced sensor systems and so on. So yeah, so next will be Amsterdam, Netherlands, circular economy and smart infrastructure. So circular economy, Amsterdam is working towards becoming a circular city, focusing on reducing waste and promoting recycling and reusing materials. The city encourages businesses to implement circular practices where products are designed for reuse and recycling, minimizing energy waste. So smart energy meters, as I mentioned earlier, in smart cities, Amsterdam has implemented smart meters across households and businesses, allowing consumers to track their energy usage and adjust their behavior to reduce consumption. I don't think so. I've seen tariffs. So normally in demand period, for example, as I mentioned, in the morning or the evening, the tariff is different to the non-demand period. So people are encouraged to use the washing machines and this in the afternoon session as compared to evening or early morning sessions. So the government is trying to control them by putting tariffs. I don't think so. I've seen again in India. India is putting smart meters into places. So soon we will see the tariffs here as well. That means they will measure the demand and they will encourage to distribute the demand. They will put high rate on these particular demand periods and less on that. So to balance the consumption. Renewable energy and electric mobility. The city is heavily invested in electric mobility with an extensive network of EV charging stations and incentives for electric vehicles use. Amsterdam is also deploying a solar panel for public buildings and private homes to reduce reliance on fossil fuels. So here was Amsterdam, and next comes Barcelona, Spain, the smart grids and renewable energy integration. Smart grid energy. Barcelona has implemented an advanced smart grid that allows for real-time energy monitoring and management. This helps optimize energy distribution, reduce losses, and ensure efficient use of it. Of course, what we spoke about, using the energy efficiently. We need an advanced system to close the demand and supply channel. So it's a feedback control system. So feedback control system always helps to control our usage. Renewable energy integration. The city has integrated solar panels, wind energy into its infrastructure. Many public buildings and streets are powered by solar energy, helping reduce reliance on non-renewable sources. So that's our final target, is to ditch the fossil fuel usage in generating the power. So energy efficiency in buildings. Barcelona has implemented smart building system that use sensors to monitor and control energy used for heating, cooling, and lighting, thus reducing energy consumption. So we have already discussed about that. So this has been practically done in Spain, Barcelona. So next slide is about Denmark. So what do they do? Goal is carbon neutrality by 2050. Actions that Denmark has been a leader in wind energy, with over 50% of electricity now generated from wind power as of 2023. The Copenhagen's climate plan aims for 70% reduction in CO2 emissions by 2030 compared to 1990 levels. So results in 2021, Denmark's renewable energy share in total consumption was about 38%. That's great achievement. Okay, so next comes the Sweden. So net zero emission by 2025. So Action Sweden is investing heavily in renewable energy, especially hydroelectric wind and solar power. Carbon tax and subsidies for electric vehicles are central for Sweden's strategy. So yeah, you tax them so that they move to electric vehicles, and you pay them in intensive. That's the best way to optimize or show the citizens the directions to have less emissions. Results: Sweden reduces its CO2 emissions by 25% between 1990 and 2019, despite growing GDP. It's awesome, great. Over half of Sweden's electricity comes from renewable sources, with hydropower and wind being the largest contributors. Hope India will also achieve, because it's working hard towards that. So now comes the Costa Rica. We have carbon neutrality by 2050. Actions: Costa Rica relies heavily on renewable energy, especially hydropower, wind, and geothermal energy. It has become a global leader in sustainable tourism and forest conservation. Results is 2020, Costa Rica produced about 99% of its electricity from renewable sources. The country has reported over 2.5 million hectares of tropical forests, helping to offset carbon emissions. Wow, this is great achievement, right? So I think India is in line with this. India is also kind of restoring. So now comes the Germany part. Somebody has to mute their microphone, I guess. Anyway, so Germany, we have carbon neutrality by 2050. Actions: Germany has been at the forefront of the energy Wende, in national policy focusing on transitioning to renewable energy, improving efficiency, and reducing nuclear power. The country has set ambitions in renewable energy targeting, including increasing wind and solar power capacity. So we have seen most of the countries are moving towards wind, hydropower, and solar. So Germany is currently the fourth largest producer of wind power globally. So 45% of its electricity comes from renewable sources in 2020, with solar and wind contributing a large share. So that was Germany. I think that was my last slide. So yeah, so what do we conclude here is to get rid of fossil fuel, we need electricity. We cannot get rid of electricity. We need generation part. We have to change. And generation part we have to change by using renewable sources. And once we generate that, it's not enough. We have to plan to use it efficiently as well, by having smart cities, plan the infrastructure, and use technologies to use the energy efficiently. So this here I conclude my presentation. If there is any questions, you're most welcome to ask. Yeah, I would stop my slide presentation, and we can have open discussion if you like. Madam Hajira, to you. Yes, Madam Hajira, are you with me?
Once again, good evening to all participants. As we conclude with this enriching session on sustainable urban energy planning and smart cities, it's my privilege to extend a heartfelt vote of thanks to our distinguished speaker, Mr. Mohammad Abdul Jawad. On behalf of Maulana Azad National Urdu University and the organizing committee of the Faculty Development Program, I would like to express our deepest gratitude to Mr. Jawad for sharing his profound insights into one of the most critical challenges of our time, integrating sustainable energy solutions into urban planning while leveraging smart technologies for building the cities of the future. From exploring advanced energy systems to understanding the role of smart technologies, his talk has equipped us with actionable strategies that we can adapt in our respective domains. Second, I thank Mr. Jawad for your invaluable insights, and we sincerely hope to have you with us again in the future for more such inspiring sessions, sir. And thank you so much. And thank you all participants for your patient listening and active participation. Now I request the participants to fill the attendance cum feedback form before leaving the session.